Okay, we begin the process by removing the carpet. Simply pull that out. There's a little Velcro here and there that needs to be removed, and then pull it out.
This tub comes out next, right, Mike?
Yep. And it's just a flexible panel that pops right out. Now, this is what you have to realize, is that there is some danger involved with playing in here, but we're going to make it as safe as possible by first removing the negative lead from the battery under the hood, and then also removing this screw and that screw, which lifts this cover. And then you'll see the red kill switch. Pull the plastic piece off, which is not easy. Flip the switch, and 5 minutes from now the car will be totally safe. We'll put this back on so it isn't flipped by accident, and we remove the small screw that's right here. It's an 8mm screw. Screw that out, and that cannot be removed until this switch is flipped, so it keeps it safe.
Battery. Interesting thing I found about this battery, Mike, is I cannot buy one from the Honda dealer that's this size.
That's right.
This is the original.
Yep.
And I'm still looking for a way to find exactly that size battery. I didn't want to go to a heavier battery.
Well, you know,
remove here.
Yep.
I'm going to go right underneath the carpeting, I guess.
Now, because most of you don't have an upholstery tool, I fabricated some out of some stainless steel that I happen to have. And it works pretty well.
Sticky little rascals.
Yep. Now you'll notice that there's screws all along here. These two screws are very difficult to get out because they've got a fine thread and there's very little holding them in there. So usually you have to take a Phillips screwdriver and really gently try to unscrew it. And if you're really gentle, it will unscrew, and then once you get it started so you can grab the head, just pull it straight out.
Mike and I just discovered a little trick here with his tool because it's so nice and sharp. Both of these were giving us major difficulty coming out, so with this tool I can actually go right under there and pull it.
Right. Third use to the tool.
Manual, yep. Very nice, Mike. So, now, where's this?
So that exposes
come out.
These two 10mm here that have
10
to
mil
come
in the
out.
back corners.
And then I think this thing will pop out after that. The cross piece, all the screws on the front side and the screws along the back side here all have to come out, and then it simply lifts right out, as Ian's going to show us. And this is where you scratch your upholstery up if you're not careful. That's the proper technique. And now that you get that out, we should be pretty well loose. Take the cover right off. Now, while it's possible to do this battery removal and reinsertion with the seat in place, it's much easier, especially using our new tool, if the seat's removed. So now we're going to remove the wrenches out and make sure you got at least a 3/8 set, because these things are really in there. They recommend replacing them with new bolts when you do this, but I believe if you put a little dielectric grease on them and you tighten them up nice and snug, they should be fine, but you do what you think is right. Okay, now that you got the 4 bolts out, and I know they were tough, but you know, they didn't want you to go flying through the windshield if you got in an accident. Tip the seat forward by pulling the little lever. Lean it to the driver's side while pulling the bottom out slightly. And now what you're going to do is you're going to remove the seat belt. That can also be pretty tight. Okay, now you can take your seat right out of there. Get it out of your way. Careful you don't scratch or bump the paint when you come out. And put it somewhere safe. I'm going to take these covers off. They come straight out. For those of you who have Mima plug and play, you'll have a little notch in the side there. That won't interfere. And Ian has the original hardwired harness for Mima. So it's really just everything's buried within that wire, so it really looks like a stock system from this standpoint. Before we continue, you need to test to see whether the high voltage is actually off. There's a small residual charge that's held in the capacitors, and you don't want you to touch anything and get a shock out of it. So take your meter, make sure you got no voltage across those two terminals to switch off, and then you can proceed safely from that point. Battery inlet vent is attached with a 10mm screw at that corner right there, so you remove that completely. And this allows you to gain access to the two 12mm bolts that are holding the back end of the battery pack in, which we'll get a good look at once Ian gets that loose. Okay, so Ian is reaching down with the wrench to loosen those two bolts, there and there. That's the main reason we're removing the cross piece, is to be able to gain access to that. The people with Mima are going to have to remove the fan and temporarily pull the battery temperature sensor back out again. We'll install it again later. It's always a good idea to hold the nut with a pair of vice grips so it can't twist itself off. The battery pack is stabilized with two aluminum support arms. Those would need to be removed in order to get the pack out. One of them is in the front, as we're looking at it here. And the other one is back there and passes under the harness.
This is a 10mm.
10mm, yep. Okay. Then we remove those two top bolts, which are not electrically hot at this point because the battery pack has been split in the center. So this is all safe to do. And the rear cross piece does not have to be separated from the harness because it'll move with it, but it does have to be unscrewed in order to let the pack be free. Okay, and the ground wire is also a 10mm bolt. Now be careful to identify that bolt because it's a little different length than most of the other ones. You put it right back in the hole is the easiest way to keep it straight. Okay, so you simply loosen the bolts, pull this out, and then pull the Mima probe out and get it out of our way for the time being. Two rear battery supports are then removed.
These are 12mm.
Those are 12s. Okay. And they look special, so you're not likely to get them mixed up with something else. Okay, the connectors have to be released with a small tab underneath, and the easiest way to get them moving is to use a flat blade screwdriver and just kind of pry them once you get the thing pushed. Same with the BCM connectors. All of this is, of course, expecting you to have a delicate touch and be respecting the wires and not yanking on them too hard. You know, this all is fairly simple to do without a lot of force being required. And if you're using a lot of force, there's probably something wrong. Okay, and the last one is the fan connector over on the very corner right there, which has got another little prong. Okay, then all of this can be folded back. And then the final disconnect is these current probe connectors that are still attached to the battery pack. There's 3 of them. The people with Mima have a adapter there. None of that will be a problem for us when we go to put it back together, but at this point it's Okay, so now it's a good idea to fold
have
these,
to-
disconnect all these little proby things. Get your wires folded back so they're out of the way. And then what we'll do is attach the lifting probe fixture. We're going to start by attaching the two cross members. Sorry, Ian, that hole's got to be used for the big rods. So the existing screws can be put in on the far ends, and we'll leave the two center holes free for the actual lifting rods. Now the purpose of this angle iron is to spread out the lifting forces so the bracket doesn't bend. So we're basically spreading the force through all three mounting supports. Even though we're only lifting the center one, it forces the angle iron to lift the two side ones as well. So it spreads the load out and gives us a nice, real strong support. I'm thinking I'm recording and I'm just on standby. So here's the actual bolt nut that's going to be holding everything together, that single one in the middle. It's a very rugged steel one. There should be no problem with strength. Just, you can strip it out if you're a little too ambitious. So you want to get it so that it's nice and snug and you don't get any motion relative to the pack. And there you are. So there's the lifting frame. It can break easily. The idea here is you have to slide the thing off of the fixture. Now you notice if he tips it this way, there's a little tab right there. You have to lift that tab in order to get it off the bracket. And then once it's off the bracket, it's fairly easy to separate the two halves of the thing. Again, by pushing the right button. There you go. And that's the final connection to the battery pack. So now the battery pack is pretty well free and ready to be lifted out of the car. Okay, so now what's going to happen is Ian's going to lift up on his end while Dan supports that, and kind of like taking your shoes out of a pair of socks. He's going to pull it up and get it right up onto the back deck. How did that go, guys? Any problem?
Far easier than taking it out without.
Okay. Now that we've got it there, Dan can come around and we'll put it up on the table and attach the appropriate stuff. Okay.
You want to switch sides?
You want to switch sides? Yeah. Okay. So Dan's got to go first. There you go. Just set it nicely on the table. And there we are. Ready for stage 2. So while we can work on this with this bracket in place, it's probably going to be easier to remove it. And it's so easy to put on and off that we'll just remove it for the time being. Here's the Insight harness. Plus high voltage, minus high voltage, temperature board with the two inlet and outlet temperature sensors. The PTC strip passes through the board from here to here. And the harness then comes around and you have your fan control board. And then you have your outlet, and we'll see how this all goes together in a moment. Here's our battery pack on a table, ready to do the installation. The key areas that we're going to be working in are down here next to the contactors, back here next to the rear of the BCM, and over here where we are attaching to the fan enclosure. Now we're going to clean the surface of the back of the BCM where the board's going to mount with some alcohol, wipe it good, and then we're going to clean it up. Now if you notice, the temperature probes look different in yours. We had already removed the loom on this thing when we did the video, so I'll show you a picture of what it looks like when we go to the next stage. Okay, the temperature board is pre-wired to the harness and has two probes coming off of it, a short one and a long one, and it's pre-mounted to these adhesive back pads. So stage 1, you remove the adhesive backing. Helps to have good fingernails. And this is going to adhere these two pads to the battery pack, but there's screws on the other side that will allow us to remove the harness if required without removing the pads. Now we're going to apply this card carefully to the cleaned area. then press down securely to hold it in place. So when we're done, we get this very secure circuit board held on by a couple of screws. The way your pack comes stock is it's got this shield over it for some strange reason. I mean, you're really not going to have anything bumping against this, so this is more for cosmetics than anything. And when you're removing tape from any loom like this, you always want to find the end, because if you find the end, everything comes apart nice and easy. If you start on this end and you try to work yourself back against the wraps, you're going to have to cut it, you're going to stretch it, and you're going to be swearing. And I don't want anybody to swear on my account, you know, so you just unwrap this. And if you want it to be pretty afterwards, you can put it back, but I'm tending to say just wrap it up with some tape and you should be perfectly good. There's no need to get it back into this original state. Where's Paul Jr.?
He's watching a movie in the car.
Kids. You think he'd want to learn something new here, you know. Alright, and then this is split so it can be removed easily. So that's stage one, get rid of all of this stuff. Now you go down one more layer. And again, look for the end. There always is an end. And I say that, but there's actually, some of these don't have an end because they use a piece of sticky backed material to get it to see if the guy was right-handed or left-handed too. They tend to wrap in different directions. Okay. And a final wrap here, which we will replace this because this is structurally keeping things together. Boy. Yeah, finally. Okay. Okay. So now what we're going to do is we're going to separate the red and black wire on this end of the connector from the rest of them. And this is the PTC wiring. And we have one more tape to unwrap. Come on, don't fight with me. I'm a good guy, you don't have to do that. There we go. Okay, so now we're done preparing that wire. What we're going to do next is we're going to take the PTC wiring, which is going to plug in here. And we're going to lay it across this board so that we can see where the wire would lay naturally. And then halfway, right about over this relay here, we're going to cut the wires. Now, we're going to strip the ends. Well, it turns out there's a lot of different types of pliers that are used for stripping wires. Here's one type where you grab the wire and it grabs the other end and pulls it to strip it. Here's a less expensive one that's more readily available. It basically comes together with a stop that doesn't allow it to close completely. And this type is more than adequate for what you're doing. We'll leave about 1/4 of an inch, 3/16 to 1/4 of an inch of wire. Okay, the wires are stripped. So now what we want to do is we want to put the plus PTC on the red, on the plus PTC wire. So the red goes to the plus PTC wire, and you just place it into the connector, making sure that all the strands are going in and that you're clamping down on the wire and not just the insulation. And don't be afraid to torque this thing down, because we want to make absolutely sure this is secure. Pre-twist the wires, which will help the strands not get separated when you go to put it in. And carefully place the wire in there. Tighten her down. On the other side of the board, we follow the same color codes. And in this case, if we remove this, it might make this a little easier. Now you're probably saying to yourself, oh gee, what happens if I want to take this off of the battery pack and send the battery for repairs or whatever? What would Honda think of this? Well, I have a solution, which is basically it's a small connector that basically connects this to this and that to that. So when you want to remove this board, you take the two screws out. You can leave the little pads there. Place your red wire in there, the other red wire in here, and the same with the black wire. And then you'll now reconnected your PTC wires and everything will work normally. So while this is cutting wires, it's not cutting wires in a way that's not recoverable. Now we plug the connector in, and we're done with the PTC wiring. If you want to get fancy, you can tape these back up again. It's really not important for functionality, but as I said, if you want it to look good, you can connect those wires back with some more tape. Now whenever you're trying to tape in a tight area, pull off a piece of tape and then carefully wrap the tape so it doesn't stick to itself. A nice uniform wrap. And this will keep all the wires together and give it a somewhat stock look, since black tape was their primary method of attaching this anyways. And we'll finish it off with one more piece of tape. So now you have two wires coming from this connector. Let's zoom back just a little bit. I'm doing this video all by myself, so excuse me if some of the stuff gets missing. So let me stop for a moment. So now we're going to take the first of these high voltage, the temperature probes, and this is the air inlet. This is where the air is being drawn into the pack this way. So we want the active face of this temperature sensor, which I can probably zoom in to give you a better look at. You can see how one side has a little bump right there, and the other side is pretty much flat. Well, the bump side is where the temperature sensor is, and that's the side you want to face to the airflow. So when we're all done, this is going to want to sit here. Now, the issue with going through here is this has got a gasket in it that helps keep the air drawing in through the path that it was designed to draw it in through. So you have two choices. We can either tape this to here, which is going to interfere with the seal, or we can drill a small hole through here in order to get through this web here without influencing the battery in any way, and then we can place the battery probe right where it needs to be. So let me get a drill and I'll resume. Okay, so I have a 3/8 of an inch drill, which I'm going to drill a hole right there. Now we're going to place the probe down through the hole. Make sure it's twisted in such a way that it will be facing the airflow. And that's it. To help keep the wire in position, I'm going to supply you with a little bit of this aluminum foil tape, and you can use this to secure the wire as it's passing into there. You simply peel the backing off and then apply this right here to hold the wire in place and to seal the hole to some extent. Not that it matters, you're going to be drawing cabin air into here anyway, so whether a little bit comes in this way or not isn't a big factor. Okay, and that takes care of that temperature probe. Now let's go to the other side, the fan end of things, and apply the probe there. As anyone that's installed MEMA knows, this fan has got some 8mm screws that fit into these small clips. And when the fan is removed for the first time, you have to grab these clips with something, and I find that vice grips work pretty well. And that's to stop the nut from twisting and damaging the enclosure. So now you can take your... You might have to have someone hang on to that. This one has been opened before, so it's fairly easy to come out. Actually, I don't even need to hold that on these because they're still in there. Just barely in there. If you have MEMA and you have a temperature probe going into this pack right here, you don't have to change that at all. And now we take the fan out so we can see what's going on. Now we're going to mount the outlet temperature probe, which is the longer of the two. To mount that, we simply are going to route it down around the back corner of this BCM, around the front corner of the BCM. We want to go underneath this orange loom. Through the little opening. And have it ready to go down inside the pack. Okay. Now we're going to take a little closer look at the preps over here. And now what we're going to do is we're going to take a 3/8 electric drill, and then right about there, in the radius portion, right next to the corner of the handle, have a nice clean hole. We're going to pass the temperature probe through the hole inside the pack. Okay, now that you've got the probe through the hole, we're going to take this material and fold it sticky side out backwards like this, and then as carefully as we can we're going to lay it down so that the bent area touches the material, touches the wire, and then bring the thing down, stick it down securely, and now we're holding the temperature probe out of the way, passing it into the box, and we're going to take a look inside the box to see how we orient it in there. What we're looking for in here is, since the air is flowing out of the box, we want the bump on the temperature sensor to be facing inwards, just the way it is now. So now all the air that's being pulled out has to pass by that probe, and it will hit the active side of the probe first, which should take care of our monitoring of temperature. Now that we've got the fan replaced, this is the time to improve the cooling efficiency of the fan over what the stock system had, to make up for any small inefficiencies we may have caused. We do this on the MEMA system in order to increase the efficiency of the fan. So take the strips that you've cut out of the supplied aluminum foil tape and lay these layers on one at a time to seal the total edge of the fan, and this way it's vacuuming the air out of the inside of the pack. Has only one way for the replacement air to come in, which is through the front of the pack where you want it to. And putting this on all four sides. On the area where the wires come off, you do the same thing. And just lay the tape right over the wires. Tape can be removed easily if you have to. And this gives you a nice well-sealed fan that will draw the air through the pack in its most efficient way. Okay, so now we're going to drill the hole. So put this board in a location very much like this, and then using one of the existing holes in the board, you drill through. Then you're going to screw the board on with this applied screw, and there's two length screws. The longer of the screws that were supplied are the ones for this mounting of this board. The shorter ones are to mount the bulkhead connector for the actual harness. Okay, so now you get this board like this. Drill your second hole. Stuff is pretty thin, so it drills relatively easy. That's why you don't want to over tighten these screws. You want to put the screws in snug so the board doesn't wiggle. See, that's a little too loose on this side, so you give it just a little smidge of a turn. There you go. Okay, so now that board's mounted. So the next thing to do is we're going to route this fan wire through the board. And just as we did with the other one, let's stop for a moment. Okay, so we want to leave some strain relief in the wires, and since the board's that wide and the wire is this long, we can have pretty good freedom as to where we cut it. So I'm going to cut it right there, kind of like right in the middle. And then this shrink that they have over this is going to have to be cut back. And we don't have to get carried away with how far to cut it, just enough so we can get good access to the wires. Alright, we trim off the excess. And now, using, I use a different technique to strip wires, just carefully use these pliers. It does just as good a job once you get the technique, but if you don't know how to do it, you'll end up cutting the wires instead of letting them be normal. Okay. Okay, this fan board has 4 connectors, but we're only going to use 2 for this. The black wire of the fan, let's see if I can get a little better view of this. Okay, just as we did with the PTC board, we're now going to connect these wires, and the blue wire is the positive, and the black wire is the negative, and you don't want little strands aiming in the wrong direction here. I'm kind of in an awkward position, so I can't see very well. You don't want to do that. Alright, there we go with the black wire. Now when this board is not powered up because the charger is not connected, these wires go straight through so that the car can operate the fan, Mima can operate the fan normally. But when the grid charger turns on, the grid charger takes over and it supplies the power to the fan, and the standard system is disconnected. So it's pretty important, like it was with the PTC, that you make sure these wires are secure and that it's working as we want it to. The grid, the blue wire is the plus 12 as labeled on the board. Don't be afraid to tighten this down. Don't break the board, but I mean, you want it secure. And just as we have one of these supplied for when you want to connect your PTC back up. I'm going to supply you another one of these so you can connect your fan back up if the time comes that you ever have to. It wants to be secured in a way that won't interfere with anything. So we're going to take it around this edge, bring it down, and then tie wrap it to the wire from the fan in order to support it. And we want this down low so that the foam block that goes on top doesn't interfere with it. And we do the same thing here. By keeping it down low, we are sure that it will safely flow underneath the foam. Okay, now we can cut off the excess. This way, when the foam block comes down, it can seat securely and the wire is below it, so there's no issues with interference. Now let's look at how we hook the high voltage wiring to the side terminal board. We'll start with the negative lead, which will be going to this location right there for the negative lead, which is right below the main contact, and just down here, which is just below the output contact from the contactor, the main contactor. Very much the same place that the resistor went, but we're not going to tap the resistor, we're going to just tap the same bus bar a little further down. So the harness is made up of the end is made up of two shielded covered pieces of loom. The one with the fuse is the positive, the one without the fuse is the negative. Don't mix them up, it's not going to be healthy if you do. Okay, so we're going to start by removing this screw. Now, anytime you're removing a screw that's tight, the thing you want to make sure you do, let's get a better view of this. Now, these screws want to be tight because we're passing current through them. This particular one isn't as important as the bottom one will be. So now we're going to take this screw out, and I hope you can see. Okay, it's going to be pretty tight because this is what's actually mounting that bracket for you. And you've got to take the screw right out, and then you're going to put it right through this negative terminal, and then put it right back. Make the wire come off at a slight angle like this, and get it tight. There. Now the fuse will go next. Let's move the camera to a better position so we can see that operation. Okay, the next thing we're going to do is we're going to loosen this bottom screw here, which is also going to be tight, and also remove it. There's already a wire there, which we're going to need to leave there. So now what you do is you take the high voltage fuse and you lay it right next to this connector that's here. And what we're going to want to do is to tie wrap the base of it so that it stays in position. So you're going to go around this connector, the bottom end of this connector, which is not so easy to do. A little trick that works is you kind of bias the tie wrap by giving it a couple of bends like this so that it can work its way around more easily. Like that. So now you're going to stick this around the connector, the other connector, and having a screwdriver to help pull it out at this point is very useful. And once you have the end of it loose, I'm now going to wrap it around the fuse. And make sure you're reaching the connector body rather than just the wire. Okay, and you're going to slide this down so it's below the surface, like this. And then snug up the tie wrap. Doesn't have to be tight, it's just there to keep it in position. Okay. Next thing we're going to do is we're going to fish this wire above the main contactor down through this area and down to that fuse, that screw that we removed earlier. Now you're going to take your screwdriver and put it through the wire that used to be there, and then our new wire, and together we're going to put it in that position, and being careful to put it in straight so you don't cross thread it. I'm going to now this is also wants to be pretty tight. So you put one hand on the back of the pack and with all of the strength you can muster, tighten it up. Don't want to strip these screws out. And basically now you just you've got your high voltage wire routed. This orange loom will protect it against any potential short circuits, and you're pretty much ready to go. Now let's take a look at how the top looks with this all routed. The final step is to take this wire and dress it down like this. There just happens to be a piece of loom there now. Let's do the same base strip redirecting trick to get it around it. And there it is. Cut the tie wrap and we're done. When we're routing the high voltage wires, it's important that this wire, the negative wire, gets pulled back this way as much as possible when it's tie wrapped down here. This will stop it from being interfered with by the aluminum cover that comes down on top of this. But this area here has a little bit different issue, and so does this area. So I'll show you what we want to do to correct those issues. Okay, in this area we have a couple of issues. One of them is that when this material is pushed back down, it wants to basically fall right where the high voltage lead wants to go through. And this is really the best place. It's got no sharp edges, it's a direct route. So rather than route this in a less than optimum way, I'd rather take some of this foam away. So what we're going to do is we're going to take a magic marker and we're going to mark where the foam needs to be removed by going over it like this and making a line. And at that point we have corrected the problem. Now we need to go down about this far, and then the rest of this is removed right from to the corner. So basically we're going to cut this piece off like that. And a simple way to do that is to use a serrated steak knife or a hand saw or many other different tools. I'm going to use a serrated blade saw, serrated blade knife. We'll simply take a serrated blade knife and there you go. And it gives a little bit more room here. So we still get the protection from too heavy a weight being put on it. We protect these wires so they can't get crushed. And the other side is clear, and the center is clear because of how we routed the wires. And that's the way you want to dress the final wiring in your battery pack. Now when you go to put this back in the car, you're going to discover that there's another issue that has to be resolved, which is in this area, this piece of foam is going to be occluded. And this goes into the pack more or less like this. So what I'm suggesting we do here is we simply remove this whole section of the foam. That way we have no issues with interference. Got good access. If you have to change the fuse, you can reach it. A hand jigsaw or any other kind of cutter should take care of this. So now, as you see, all this area where the fuse is going is now separated from here, and we shouldn't have any issues with interference. And that's the final piece of foam to be cut. Drilling guide for putting the bulkhead connectors through a piece of metal. So I found that it was easier to do this from the inside rather than the outside of the pack. So Ian is going to apply that in the location he likes, more or less towards the bottom of the thing, but not so close that you're hitting that rubber grommet thing. Okay, and we'll take another look at that from the inside here. Okay, never seen one of those, and it's probably the best tool for drilling through sheet metal that there is. That will give you the ability to make the 7/8 hole that you need to put through this panel, and also the secondary panel where the extension cable is going to go through. And then an 1/8" drill is what's required for the other 4 holes. So let's get Ian a nice little drill and let him do his hole piercing. Okay, the best way to get accurate holes is to put a backup plate there and to use a center punch in order to indicate where the holes want to actually be located. Now you'll notice there's actually a little X on those things. Accuracy is important here because you don't have a lot of play. You got to get a little more solid hit than that. Ian can't hit the end of the punch good yet. Got to get him one of those hammers with a rubber tip on it.
You okay?
You're not hitting that thing very square.
Well, we're just starting it, right, for the drill?
Well, yeah, but you want to have a reasonable dent in there. If you got a good dent, you're all set. That's why. Okay. Is that position working for you, Ian?
Pretty good.
Or you think you could do better from the backside?
I think it's pretty good. People, like you already mentioned about the rubber.
Right.
So if you just gotta be careful if you get low.
Okay. Now you switch to your big bit and finish that center hole by going right through. Now some people will get a bigger or a smaller one of these drills because they came in a set of 2. One was 7/8, which is the correct size, and the other one was bigger. So if you get a larger one, make sure you only go in 7/8 to get the clearance that you need. Okay, so here goes. Now that's probably a pretty raggedy hole, in which case you got to get a file and clean it up, or a deburring tool, whichever you've got handy. A good file for that is a chainsaw chain sharpening file, which is a nice fine round file. We'll clean this up and let you see what it looks like when we're done. Start with a flat file, surface flush. All the big sharp edges that are coming out. And then check the inside as well. There's a little sharp edge there. If you can't get in there with the file, that's where you want the round file. So come in from the outside and just kind of put it at a sharp angle so you can clean that up. Block with some coarse sandpaper, file, or a deburring tool. All can do this job. Here's a deburring tool right there, which you basically pull around the hole. It's important that you get it reasonably good before you try that, because it gets caught easily on any sharp edges. When you're all done, you want to have it clean so you can't get cut on it without any shards of metal hanging out. And of course, we want to immediately vacuum up all of these pieces of metal so that you don't have them floating around in the back compartment here. So I'm going to go get the vacuum now while Ian's cleaning that up. So get in there. Alright, that looks good. Hey, the key here is that you don't want any pieces of material left down in there. And when you're done, you want this to be as clean and burr-free as possible. Now we get to test the battery lifter on its ability to put the pack back in place. It's fairly easy to carry, not much strain. Guys are carrying it with one hand. Carefully place it up on the rear deck so you don't bump any of that stuff on the left hand side there. Now Dan's going to jump in the car and see if we can the front of the pack has two little arms that stick out that have to be on either side of the duct. So the front end has to go down first, and then as you put it in, kind of like putting your toes in a pair of shoes, you put those in first and then you can drop the heel in. So Ian's got the heel, Dan's got the toes, and let's see if they can put the shoes on properly. Okay, there it goes. And Dan's got one hand free to get stuff out of the way, and Ian can manipulate the back end quite easily. So I would say it's a lot easier and a lot better control than if you didn't have it. And that's what the whole thing was all about. That was pretty easy. And it seemed to me like you guys had full control the whole time without any awkward positions or anything.
Easier than one person by far.
Yeah. Okay. At this point, we're going to attach the connector to the holes that we made. Dan's demonstrating that procedure. Be careful you don't over tighten the screws. You just want them nice and snug and secure. Since we have an extension harness being installed here, that little cover and yellow label gets moved to the top rather than the bottom on the shelf that goes here. Plug the connectors in. Okay. Screw the fan shroud back on again so the air duct is correct. And we give a visual check, make sure everybody's installed. The ground wire over there, has that been tightened? Or is it just hand tight?
It's just hand tight.
Okay, make sure you get that tight.
Good job.
Those top ones there, make sure those are secure as well. Those two. Don't be afraid to torque those guys down. That'll be good. Don't break them off either.
Bracket for me to do. You want this bar yet? Yeah.
Now that back bracket is in,
Yes, I tucked that.
and then we need to put the front bracket in.
That's where it goes.
It goes from there to there.
Need 2 more of those screws.
Well, these are the screws that came out from in there. I don't.
Now,
All right, just pull this back and lift from the bottom tab, get behind, and it just pops open. We'll lift gently underneath. We should be able to get this on the other side. Make sure it's folded properly on the other side. Set it back down, and it pops right back into place.
very nice, very nice. Okay, now we're going to put a hole in this thing, in this position. Now, since this is a convoluted surface, I can't have 4 screws in there all at the same plane. So I chose this position here, like that, as the best spot for doing this. So now that I've center punched the holes, which you saw earlier, like this, a good piece of steel backing gives you a nice deep impression in the metal. And by putting it up inside there, you end up getting a nice impression without making too big of a dent in the material. So now what we're going to do is we're going to drill these holes out. So you can pause for a second. Okay. Now we're going to drill the 3 holes. Okay, stop for a second. Okay, it's always good to have a clearance underneath so that when you're drilling, this thing doesn't have to also drill through the bottom plate. So we're going to do it this way, a nice slow speed. Yeah. Okay, now we're going to clean this up, and you can probably watch that procedure as well. Okay, you can see that these shards are kind of attached quite well and quite strong. So the first thing you do is you kind of take the bulk of them off. Now take a round file. Now this is fairly coarse. Most people have a little chainsaw file like this, and that works pretty nicely. Just hit that at about a 45-degree angle on the edge. You see how easily that everything came off. Check this side. That all looks good. And then as far as these clearance holes, just hit those with a flat file. There you are. Never cut yourself with that. The extension harness is screwed in and securely locked. These connectors are nice because you can feel when you're there. And since the high voltage switch is still off, you can touch those pins without any danger of getting a shock. Pass it through. And you kind of want to not have to twist it too hard, so pick the holes that work the best.
Can't
Yep.
see the holes. You had to put the layer.
Dan, is there anything I can
Hate
do
to tell
help?
you, but it's better off if you.
Well, you almost want to do that the other way first to determine where you want to be, because if this is wrong, you'll have to twist it 180 degrees. Okay, so once you get it positioned, stop the screw. The yellow label should be on there at this point. Okay, so you put the yellow label on, just kind of roughly get it in position. It's got an adhesive back, which isn't going to help you much at this point. And then don't forget to put the little cover on at this point. Okay. So put it on like that. Alright, again, you just snug it up nice. Okay, and now the small tail underneath can be attached. And I can't do it from here because I can't see. If you're wondering where all these hands are coming from, we got plenty of help today.
I can put it in.
And it's beginning our snowstorm, which is, always seems like we're doing these videotaping when it's raining or snowing. And there you have it. Now we just put the you don't want to put that in yet because the big cover's got to go on first. So just kind of get that roughly in the right position. And there you go.
Nice. That looks nice.
The left-hand foam block needs to be cut out, but the cutout depends on if you've got MIMA installed or not. So in this case, this is a car with a plug-and-play MIMA harness. Install in it, and you can see how this current probe sticks up, and we had to cut the foam out for it. Well, if you're going to put in a grid charger harness as well, you've got to cut it out larger. I mean, the original piece looks like this. Which if you have both, you may want to just cut it right out. But in this situation, we're going to leave this piece there. And now we've got all the pieces in place, so now let's put the cover on. Oh, one more thing. Good. Turn on. If you don't have the MIMA plug and play, all you need is to cut out this much in order to give you access to the fuse. Okay? So once you're at this stage, the last thing to do is to put your cover back on, which Dan is going to demonstrate. Make sure it fits nicely. And you can see how the wires in there are right out of the way. There's no danger of damaging them. So after all your work, you're almost ready to go. Put the 8mm screw in to hold the cover in place. Turn your switch on. Put your red lock back in place. Put your cover back on. Go turn on your 12-volt system by reconnecting your battery. Put the rug on top of this. The installs that have the extension harness and the ones that don't. The ones that do, you simply reach over, open up this little compartment, and there's your charger jack. Very easy to connect to. The ones that don't, faced with pulling out this insert, going underneath here and plugging your charger in there, which is not impossible, but it's a little difficult when you realize you're going to do this underneath the cover and you can't see. Now, I've driven around without this cover on for some time, and that was also another possibility. So that's the difference. Convenience or being a pain in the ass. It's up to you. Be doing it without the extension harness. Plenty of wire in here to connect it, but it's much easier up on top. And there we have a typical charge setup for the extension harness version. You basically connect your charger. See how many volts you have, and you're ready to charge. Now, in order to keep the thing weather tight in case you don't have a garage, just simply put a piece of 2x4 right there. This will leave a little space for air to get in and for the cords to pass in and out, and you should have plenty of ventilation, and you're ready to go. So I wish you all the best of luck in reconditioning and keeping your battery balanced with this device, and if you have any problems, you know how to get a hold of me, 99mpg.com. Contact us, and you've got my phone number and all the information you need to get a hold of me. Okay, good luck.